Again, we're dealing with straight lines that look like this. Y equals mx plus c, or c plus mx. The order over here doesn't matter. The important things are the y is by itself, and if it is, we can extract those two pieces of information. The gradient m, the number next to the x, and its sign associated with it, and the number c, the y-intercept, and the sign associated with it. It's called the gradient intercept form. Now we wanted to, this time, be able to, from written information, pick the right rule for the straight line. And we want to do it in a way where we're not using a formal method, because we want to see if there's a logic way to do it in our heads. So this is the lesson from Mathletics, equation from point and gradient. Now there's a formal way of doing this that I'll show you later, but I want to show you a way of doing it using your logic. Now let's have a look. Y equals mx plus c. The gradient here is 9. So the number in front of the x is 9. Oh, well, they've all got 9 in front of the x with a y by itself. So we've got to be able to figure out the extra bit. Now the coordinate 0, 5 is x equals 0, y equals 5. That's actually the y-intercept here. So this is an easy one. The equation y equals mx plus c is y equals 9x plus 5. Here we have a gradient of 5, and again, well, they've all got the same gradient of 5. They've got the y by themselves. Let's see if it tells us the y-intercept. The coordinate 0, 1, that's x equals 0, y equals 1. Yep, 1 is the y-intercept, c. So y equals mx plus c, y equals 5x plus 1. That's the one. Well, easy, isn't it, so far? Well, they do get a bit tricky, and I'll show you what to do. Well, here's where you could go wrong. If you just bolt in, you might think y equals 2x plus 7. This is easy, and choose this one. But you'd be wrong. 1, 7 is not the y-intercept. It's over here. The y-intercept's here. Now this is where understanding gradient on a straight line is very important. Remember, the gradient stays the same no matter what 2 points you pick, and the gradient of 2 really means a vertical distance over 2 of 2 compared to every 1 horizontal distance, because 2 is actually 2 over 1. So for every 1 across, we go vertically 2. Now that works this way, 1 across, 2 up. But it also works in reverse. 1 backwards, 2 down. So where are we here? Well, we're at x equals 1, we know that, there it is, but y value is 7. So if we go across 1, then we have to move down 2, because the gradient's 2. Remember, because it's the same as this. This way 1, up 2. This way 1, down 2. We're using the same gradient, so if we started at 7, we went down 2, we're at 5. So the correct equation has a gradient of 2 and a y-intercept of 5. It's this one. Okay, let's see. Again, you'd be wrong if you said the equation is y equals minus 1x plus 8. That's wrong. That's not the y-intercept. It's over here, look. Okay, so here our knowledge of gradient's handy. Now what does this mean? It means minus 1 over 1. So for every 1 we go across, we go down 1. There we go. But remember, it works in reverse as well. So we'll go this way 1 and across 1. So we can go across 1 and up, across 1 and up. Well, how did I know? Well, that's because I'm at x equals 2. So I've got to go 2 lots. 1 across, 1 up, 1 across, 1 up. So I'm at y equals 8. 1 across, 1 up, I'm at 9, 1 across, 1 up, I'm at 10. So the correct equation will have a minus 1 in front of the x. Remember, the minus sign is okay. And a 10. Alright, what about this one? Here we have a gradient of 8, which was really 8 over 1. Remember, vertical distance 8, horizontal distance 1, passing through minus 4 minus 8. Now again, we know it's not y equals 8x minus 8. That's not the y-intercept. We've got to work towards it. So what does that gradient mean? It means for every 1 across, we've got to go 8 up. That's heaps, isn't it? We're at minus 4, so we've got a few steps here. We've got to go 1, 2, 3, 4 to get there. Well, each time I go across one, I go up 8. Now, if I start at -8 down here, if I go across one and up one, I'm back here, right here on 0. I've got 3 more steps to do of 8. 3 more steps of 8 is 24. 3/8 is 24. So my y-intercept is going to be 24. So the correct equation is y equals 8x plus 24. Alright, let's have a go at this one. They all have a gradient of -7, as you can see. This is not the y-intercept. Now, what does this gradient mean? It means a vertical distance of -7 compared to, remember this whole number can be written over 1 unit. So, let's see how it works. For every one I go across, I go down 7. Now, I'm at -2 away this way. So I've got to go twice down. I'm starting at y equals 9, so I go across 1 and down 7. 9 minus 7 is 2, so I'm at 2. Last step, across 1 and down 7. Well, 2 minus 7 is -5. So the y-intercept is -5, which is that one there. Okay, this is the one I wanted, a quarter. Well, it's done exactly the same way, the greatest a quarter. Remember what it means, that's the important thing. A vertical distance of -1 for every 4 I go across, horizontally. So here we are. So we've got to go across 4, and then I go down 1. That's what that means. Now look where I am. I'm at -4, -8. So that's -8 on the y-axis. This is -4 on the x-axis. So if I go across 4, I'm sitting on the y-axis and I've got to go down another 1. Well, if this is -8 here and I go down 1, I'm at -9. So the correct rule here is a gradient of a quarter, minus a quarter, and a y-intercept of -9. Okay, here we have a gradient of a half. This is what it means. Vertical distance of 1 for a horizontal distance of 2. And that's not the y-intercept. There it is there. What does this gradient mean? Well, for every 2 I go across, I go up 1. I don't want to go that way, of course, because it works in reverse. So for every 2 I go across, I go up 1. It works the other way. For every 2 I go backwards, I go down 1. There it is. So if this was 7 here on the y-axis, and I go down 2, down 1 I should say, I go across 2, I go down 1, from 7 minus 1 is 6, so it's got to be this one here. Okay, one more for luck. I hope you get the idea. I hope these are just not copied by you on yours. So look, understanding it's really important. So here we have a gradient of -1/2. What does it mean? Vertical distance 1, horizontal distance 2, and it's going down to the right. We're going to start off now at this point here, -2, -9. I've got to get to the y-axis, so I've got to go this way. So for every 2 I go horizontally, I go vertically 1 unit, and of course if I go this way I've got to go down. So 2 across, 1 down. Now if I start at x equals -2, and I go 2 this way, I'm on the y-axis. Now I'm sitting there on the y-axis at -9, and I've got to go down 1. So I'm at -10. So the correct rule is this one. Y equals mx plus c. M is -1/2. C is now -10. So using your logic will help you understand this work, and I'll show you a more formal way of doing it later. But look, if you've got a picture like this, it's nice and simple once you get the hang of it.